When the crew members of the Starship Enterprise pull into orbit around a new planet, one of the first things they do is scan for life forms. Here in the real world, researchers have long been trying to figure out how to unambiguously detect signs of life on distant exoplanets. They are now one step closer to this goal, thanks to a new remote sensing technique that relies on a quirk of biochemistry causing light to spiral in a particular direction and produce a fairly unmistakable signal. The method, described in a recent paper published in the journal Astrobiology, could be used aboard space-based observatories and help scientists learn if the universe contains living beings like ourselves. In recent years, remote life detection has become a topic of immense interest as astronomers have begun to capture light from planets orbiting other stars, which can be analyzed to determine what kind of chemicals those worlds contain. Researchers would like to figure out some indicator that could definitively tell them whether or not they are looking at a living biosphere. For instance, the presence of excessive oxygen in an exoplanet's atmosphere might be a good hint that something is breathing on its surface. But there are plenty of ways that non-living processes can generate oxygen molecules and trick remote observers into believing a world is teeming with life. Therefore, some researchers have suggested looking for chains of organic molecules. These living chemicals come in two arrangements, a right-handed and a left-handed version that are like mirror-flipped images of each other. In the wild, nature produces equal amounts of these right and left-handed molecules. Biology breaks this symmetry. Frans Snick, an astronomer at Leiden University in the Netherlands and co-author of the new paper, told Live Science. This is the difference between chemistry and biology. On Earth, living creatures select one molecular hand and stick with it. The amino acids that make up the proteins in your body are all left-handed versions of their respective molecules. When light interacts with long chains of these different-handed arrangements, it becomes circularly polarized, meaning that its electromagnetic waves will travel in either clockwise or counterclockwise spirals. Inorganic molecules won't generally impart this property to rays of light. In previous work published online in the preprint journal Archive, Snick and his colleagues looked at freshly picked English ivy leaves in their lab and watched as the chlorophyll, a green pigment, created circularly polarized light. As the leaves decayed, the circular polarization signal grew weaker and weaker, until it entirely disappeared. The million-dollar question is whether or not organisms on another world would exhibit a similar favoritism for single-handed molecules, Snick said. He believes it is a fairly good bet, since carbon-based chemicals best fit together when they all share the same handedness. His team is now designing an instrument that could be flown to the International Space Station and map the circular polarization signal of Earth to better understand how an analogous signature might look in the light of a distant planet. That will be an extreme but worthwhile challenge, Edward Schwieterman, an astronomer and astrobiologist at the University of California, Riverside who was not involved in the work, told Live Science. Capturing an exoplanet's light means blocking out the light from its parent star, which is usually around 10 billion times brighter, he added. If the world is alive, only a tiny fraction of its light will contain the circular polarization signal. The signal is small, but the level of ambiguity is also small, Schwieterman said, making the method useful despite its difficulty. Future enormous space-based telescopes, such as the Large UV Optical Infrared Surveyor LUVOIR Observatory, might be able to tease out this faint signature. LUVOIR is still just a concept, but would have a mirror diameter 6 times wider than the one in the Hubble Space Telescope and could probably fly in the mid-2030s, officials estimate. Snick thinks the circular polarization technique could also be brought to bear closer to home, on an instrument flown to potentially habitable moons in the outer solar system such as Europa or Enceladus. By aiming such a detector at these frozen worlds, scientists might see the signal of living creatures. Maybe our first detection of extraterrestrial life will be in our backyard, said Snick. The 12 strangest objects in the universe. Greetings, Earthlings. 8 ways aliens could contact us. UFO Watch, 8 times the government looked for flying saucers. Originally published on Live Science.